Yay, last one. So, the barometric pressure, I don't know how to pronounce that, the barometric pressure, measured in kilopascals at a height h above sea level, measured in kilometres, is given by the following formula, where P0 and K are positive constants. The pressure at the top of Mount Everest is approximately 1/3 that the pressure of sea level. So, to answer the first question, given the height of Mount Everest is approximately 8,848 meters, calculate the value of K to two significant figures. So we are given. Now we have to be careful here because we're given the height in meters. If you read the question again, it's the height in sea level above in kilometers. So it should be 8.848 kilometers. P naught, if it's the initial pressure, then in fact for this question it'll be the pressure at sea level. We're also told that at the top of Mount Everest, the pressure is 1/3 the pressure of sea level. So it means that the pressure is equal to P naught divided by 3. We substitute these values into the given formula. You have P naught over 3 equals P naught times 10 to the power of minus 8.848 times K. Using solve, we find that K is equal to 0.054. It does say two significant figures, so I might show you what I mean by two significant figures again. So if I put this into solve, so to two significant figures, we have 0.053924. So two significant figures, we need the first two values that are non-zero, and we of course have to round that 3 to a 4. So that's how come we round to 0.054. For part B, we're told that Mount Kilimanjaro has a height of approximately 5,895 meters. If the atmospheric pressure at its summit is approximately 48.68 kilopascals, calculate the value of P naught to 3 decimal places. My brother just climbed Kilimanjaro. So here we go. So the values that we are given, height equals 5.895 kilometers. We're told the pressure is 48.68 kilopascals. The symbol for kilopascals is little k, big P, little a. Just calculated K to be 0.054. And we want to know what P naught is. Again, these little lists of writing out what we know and what we don't know is really good practice for solving application questions. So putting those values into the formula, we have 48.68 equals P naught times 10 to the minus 0.054 times 5.895. CAS again. And we find that P naught is equal to 101.317 kilopascals. Part C is use the model to estimate the atmospheric pressure to two decimal places at the summit of Mount Blanc and the summit of Mount Kosciuszko. So we're given the height of those two mountains, and we just have to put them into the formula to find out what the what was it we were looking for? The atmospheric pressure is at the top of those two mountains. So for Kilimanjaro, we have H equals 4.810 kilometers. We have just worked out that P naught is equal to 101.317 kilopascals. K is equal to 0.054. Putting those values into the formula, we get P equals 101.317 times 10 minus 0.054 times 4.810. And the answer there is 55.7 kilopascals. Similarly, Kosciuszko, different height. It is 2.228 kilometers. P0 equals 101.317 kilopascals. K equals 0.054. So our formula is 101.317 times 10 to the minus 0.054 times 2.228. Evaluating that in CAS, we get 76.8 kilopascals. It's really messy, sorry. So next we're asked to sketch the graph of the atmospheric pressure for showing pressure against height, showing the readings for the four mountains from the above information. So you need to go back and actually find the information for Mount Everest as well. So we have Kilimanjaro, Mount Blanc, Kosciuszko, and Everest. And we should also note that the asymptote gain is just going to be at P equals 0. And we also know that we have our P0, so when 0 meters, so at sea level, that our P0 is 101.317. So in fact, we've got 5 points to plot on our graph. When we plot them, we can see that our graph there is definitely deteriorating. So hopefully you've had enough of a go at these questions to have some time to try some questions without assistance. Question 9 was really similar to question 8, that's why I skipped it. And hopefully you can have a go at 11 and 12 without assistance. If you do need a little bit of help, either send me a Snapchat or, of course, use the solutions manual. Good luck.